Our third speaker is Dr. Gloria Mark, who is a professor emeritus at University of California, Irvine. She researched the impact of digital media on people's lives. Her work has appeared on NPR's Hidden Brain, CNN's Chasing Life, CBS Sunday Morning, etc. Today, she will talk about attention and stress with everyday use of digital devices.
Okay, thank you. So first of all, I want to clarify, I am not a neuroscientist. I am trained as a psychologist, experimental psychology. My field is human-computer interaction. And my interest is understanding our lives, our behavior, our emotions in this digital world. So we're living in a digital world. We're like a frog in boiling water. We're not even aware of the changes that have been happening, but they've been happening at lightning speed. So this is not advancing. Do I have to point it? How do I get it to move up? Okay, so in particular, I'm very interested in our attention or lack of attention when we use our devices, and by devices I mean our smartphones, our tablets, our computers. But I'm also interested in stress. And so over the years, people have reported to me about how stressed they are when they're using their devices. And the World Health Organization has labeled stress as an epidemic of the 21st century. This was before COVID. But a recent survey shows that about 60% of people in the workplace report symptoms of stress, anywhere between moderate stress to exhaustion, even burnout. So stress is quite a serious thing. Whoops. Is there some trick? Oh, well, of course, that's the reason. There we go. So, people in my field typically bring people into a laboratory to study particular variables. For example, you want to study the effect of interruptions or the effect of social media. And so laboratories are an excellent environment to be able to allow people to focus on particular variables and control things that you're not interested to study. But in my view, it's just not possible to model all the things that we experience that can influence how we use our devices in the real world. So how can you model the ambient noise, the deadlines, the pressure, the conflicts that you have, people's career trajectories? So to really study how people use their devices, I believe we have to go to where people are. And so I go to people's real world environments and I create what I call living laboratories. Most of the people I have studied have been in the workplace. I've also studied college students. I've also studied people in their personal lives. So I've used a range of different kinds of sensors because if you want to study people in their natural environments, in my view, the best thing to do is to use sensors. So we've done computer logging, we've used wearables, we've used heart rate monitors to get a measure of heart rate variability, which is stress. We've used sense cams, which are very lightweight cameras that people can wear that take continual photos, and then you can apply face detection software to determine if there is a face present or not, and from that you can infer whether people are having face-to-face interaction. We use what's called ecological momentary assessment, EMAs, and those are very quick probes, and they're really important because they can get people's subjective perception of what they're experiencing. So it's a way for people to report what they're doing. And it's so important to combine subjective data along with this objective data. We've also used beacons, which can determine location. For example, is a person at home? Are they in their office? And we've also used thermal imaging, and this has been done in a laboratory. And thermal imaging can measure sweat, which is a very good measure of stress. So basically, we equip people with sensors. They're all in the background. They're unobtrusive. And it's really important that these sensors be unobtrusive so they don't interfere with people's normal work habits. And so, we would go into the workplace and we would, set up these sensors and basically just let them run. So the goal of these studies is that the sensors should be unobtrusive. They should passively collect data. In other words, you want the person to have as little effort or work as possible in providing the data, with the exception of these ecological momentary assessors. And you want the sensing to be continuous. So I also use a mixed methods approach. So this is combining objective measures with subjective measures. And the subjective measures could be probes that, where people report different experiences in real time, but also post-study interviews and sometimes pre-study interviews we use are really important to help understand and make sense of the data. Because there's so much variability in the real world, it's really important to select controls. So depending on the study, we choose different kinds of controls. For example, demographic controls, job characteristics, sometimes personality or people's chronotype will serve as controls. Now, there's a lot of challenges when you're working with this kind of data. The data is messy. It's very, very messy. You get all kinds of artifacts in the data. The data has to be cleaned. It's a real challenge. You do have to make decisions about the data. Compliance is an issue. Now, we go for minimal compliance, but people still have to remember to charge their devices. So if we're using wearables or heart rate monitors, they have to charge them. Phones have to be charged. Data privacy is a serious consideration because even though we de-identify data, if for any reason our servers should get hacked, it is possible, in theory, to reconstruct a person's identity because you have location data. You understand the patterns of people's behavior. And so their identity could be discovered. And last, there's all kinds of technical challenges. There's the unknown unknowns that happen. So there's so many factors that can affect our attention when we use technology. And let me just list some of these. So this is just to convey to you that this is a really tough problem. It's a wicked problem to understand people's attention and stress and use of devices. So first of all, emotions affect our attention, especially when we multitask. Now, it's not humanly possible to do two different tasks in parallel if both of them require mental effort. If one of them is automatic, yes, we can do it. So we can walk and text at the same time because walking is automatic. But as soon as a bicyclist comes and clips you off, your attention all of a sudden is directed to that bicyclist and you stop texting. We have so many unconscious actions when we use our devices. We've developed so many habits. You may or may not notice. We see our phones next to us, we automatically pick them up and swipe them open. We automatically check social media or check news or check email. These are all unconscious actions. Stress, of course, is a big factor, and I'm going to show you how stress affects our attention. Algorithms, right? When we go on the web, we leave digital traces, and ad remarketing companies and tech companies take these digital traces and they construct profiles about us, and then they target attention to us based on our profiles. For example, if you're an extrovert, you'll receive one kind of ad. If you're an introvert, you'll receive another kind of ad. We are social creatures, and email, Slack, and social media, these tap into our social natures. The same kinds of social dynamics that exist in the real world also are recreated when we're online. Of course, time since waking affects our attention. Later in the day, it's harder to pay attention. Personality, there are personality differences. I'll talk about that shortly. When you're mentally fatigued, it's harder to pay attention. And of course, if you're sleep deprived too. So we have been tracking attention duration on computer screens for about 20 years. So back in 2004, computer logging wasn't available, and we would basically shadow people with stopwatches. And every time people would switch their attention, would switch the content on their screens, we would note that with stopwatches. Not completely perfect, but fairly accurate indicator of how long people were paying attention. And back then, we found people averaged about 150 seconds on any screen before switching attention. Since then, our attention spans have declined. And over the last 6-7 years or so, we find that attention spans have averaged about 47 seconds on a screen, or more accurately, a computer window, before switching to other content. Now, this was replicated by other people. Andre Meyer, who's at ETH in Switzerland, Yerkeles and colleagues at Stanford used a system called Screenomics, where they captured every 5 seconds people's screen. So it's not a perfect measure of attention switching, but it's pretty close. And if you want to get into a little bit more details, again, the average attention duration based on this collection of studies over the last 6 years or so shows it's about 47 seconds. The median, not too much different from the median, which is 40 seconds. People spend a little bit longer on email. Productivity software refers to things like Word, Excel, PowerPoint, and they shift their attention a little bit more frequently when they use communication software. Another way to view the data is in terms of how often people switch screens. So you can think about this as how often people are actually switching content. Every time you switch content, you have to reorient to new content, and that is stressful. People change screens on average 566 times a day. They check email on average 77 times a day. This is in the workplace. This was replicated the year prior. We found they checked email 74 times a day on average. Now, this result was from shadowing people in the workplace. And we find, you tend to think of when people are interrupted, people curse interruptions from their phones and from notifications and text chimes. Sometimes other people. It turns out about half of all interruptions are self-initiated. So people self-interrupt. And so from an observer's perspective, you're observing a person, there's no external source for this interruption, and the person of their own volition suddenly switches screens or suddenly switches and picks up their phone. So there's no external trigger for this. So people are unique. We have individual differences. And so we wanted to discover what are these individual differences in people's focus duration. So we did a factor analysis on all the variables we collected. So we also gave surveys, so personality surveys. We had measured stress. So we had measured a number of different things. And we did a factor analysis, and two factors emerged. One is a factor that we label control. And control is comprised of the variables neuroticism, a personality trait that's called impulsivity urgency. It's from a survey that's called the UPPS survey. And stress as measured by heart rate variability. And so we find that there's a significant relationship between this factor that we call control and people's attention duration. So the more neurotic a person is, the more impulsive a person is, and the more stress that a person experiences, the shorter is their attention duration. And time pressure was the second factor as measured by deadlines. And strangely enough, that didn't have a relationship. So this is a laboratory study that I'm going to talk about. So we were very interested in the emotions that people experience when they multitask. And again, by multitasking, I'm not talking about people doing two things in parallel, but rather switching attention rapidly. And so we set up an experiment where people did a task without any interruption, and then they did another task, similar task, where they were interrupted and they had to deal with these interruptions. So, and of course, it was counterbalanced. We also used a thermal imaging camera so that we can look at people's sweat, which is a very accurate measure of stress. And we did find, not surprisingly, a relationship between multitasking or attention shifting and stress. But we also videotaped people when they were shifting their attention. And we find that there was also a significant relationship between the kinds of emotions that people express and when they're multitasking. So this image on the left is of the person when they're doing the task without interruptions. We applied emotion detection software. And based on that software, this person's typical expression is judged as being neutral. And the two images on the right are an illustration of showing what this person, what their facial expression is when they're shifting their attention. And the software had indicated that they experienced the emotion of anger. And if you look at their face, it certainly seems to express that. So, most people, when they think of attention, they think of it as a binary state. You're focused or you're not focused. Your attention is externally directed or it's internally focused, your mind wandering. But in studying people's use of their devices, I realized that there's another factor that's not being considered. And that is the idea of how challenged people are mentally. So you can be engaged in something like you're reading an article, you're writing an article, you're doing a calculation, and that involves a lot of mental challenge. On the other hand, people use their devices quite a lot, and they're not challenged at all mentally. So, imagine being on social media or playing solitaire. So there's a lot of cases where we're just doing this easy, unchallenging kind of work, and yet we're really engaged in it. So there are different types of attention, and to explore this, we used EMAs. So this is the framework that we developed, and it's based on two dimensions: how engaged a person is and how challenged a person is. And so when a person is highly engaged and highly challenged, we give this a label of focus, right? We call this focused attention. It's merely a label. When a person is highly engaged and not at all challenged, we give this a label of rote attention, right? Rote meaning simple, easy attention, playing solitaire, but yet you're really engaged. And if you're not challenged and not engaged, we label that boredom. And if you're really challenged and not at all engaged, we give it a label that we call frustrated attention. And let me give you an example. So when I have a tech problem, it's challenging. I'm very challenged by it, but I'm not at all engaged. It's really hard to bring myself to solve that problem, but I'm mandated to. I have to solve it because I need to use my device. So we gave people these EMAs throughout the day. We gave them 18 probes throughout the day. And people were instructed that when you got this probe, you were to respond how engaged you were and how challenged you were for the thing you were doing right now. We also gave them a mood measure. It's a Russell circumplex model of mood. And these questions could be answered within a few seconds. We gave them 18 times during the day. And so we measured this for 32 people over 5 days. And we find that focused attention seems to occur in a rhythm. So there seems to be a peak for most people mid-morning. Then there seems to be a kind of a trough. There also seems to be another peak mid-afternoon. And people don't come to work, ramped up, ready to go, highly focused. But it takes them a while to ease into a state of focus. And they also show that they have different kinds of attention. Sometimes they're focused, sometimes bored, sometimes showing this rote attention. Surprisingly, there were only about 7 instances when our participants rated being frustrated in the workplace. And perhaps it's the nature of their work or the workplace they were in, but we didn't find that. So what we did find is that people are happiest when they're doing this kind of rote activity, this easy, engaging activity, which could explain why people just get hooked on doing simple mindless games, or why people are hooked on social media. It makes us happy. Okay? So let me talk about another study very quickly. During the pandemic, many companies switched to remote work. And many companies are continuing with remote work. But here's the thing, when teams work remote, what happens is that people naturally slip into their chronotypes. If you're a late type, you get up later. If you're an early type, you get up earlier. And so we know from research that team collaboration is most successful when people's work rhythms are aligned. So this is a study where we had 22 teams. They were tracked over 10 weeks. We used fitness trackers to look at sleep. We also got stress. We also had people fill out daily reports on emotions and productivity. And the image on the left shows a team where the members are not well aligned in terms of their sleep and wake cycles. And the image on the right shows a team that's very well aligned. Now, here's what was surprising to us. The teams that were less well aligned, like this team here on the left, they reported being more productive and having more positive affect. Why is that the case? This is why it's so important to get subjective data. We went back into the interviews and we looked at what was going on, and it turns out these teams that are less well aligned actually communicate more. And so we believe it's the communication, especially when people are remote, that's making them feel happier. And the last project I want to talk about is the Tesserae project. So this was a large-scale data collection. We collected data from 750 people over a year. We used various kinds of sensors. We used wearables to get stress, physical activity. We used beacons to look at location if people were in the office or at home. We could, for example, look at what happens when people were commuting, because we could look at the difference in location. We could look at stress when people were on their way to the office and back. So I'm just going to talk about a few results from that project. First of all, we found that people spent 90% of their day sedentary, which is not very healthy. Now, I looked for other studies historically that we could compare with. Now, other studies in the past have used observers who followed people around with stopwatches and measured, the times they were at their desks, the times they were moving. So it's not perfect measures, but it's a reasonably good comparison. And so you can see over the years that percent of sedentary behavior has increased. And another study that I'll talk about based on this data is looking at how weather patterns and seasons affect sleep. So a number of people have tried looking at this, but they generally look at very sparse data. They might just get a few self-reports over the year. But we were able to get continuous data collection over a full year of people's sleep behavior in different locations in the country. So we could look at things like day length and season. And we find that, yes, there is a significant relationship. So people sleep less in the spring, and they sleep less when day length is longer. So I would like to thank you. You could read more about this work in my book, Attention Span. I also write a Substack about our lives in the digital age and how our world is changing and how we're trying to adapt. And I'd like to give thanks to a number of people who've participated and also funding agencies. Thank you.
Thank you for this very, very inspiring talk. I have a question about the road dimension, and that is in our, I don't know, I'm not from the field, but in our attention economy, I would say, there seems to be this flip potentially between a momentary happiness, being rote, and regretting because the doom scrolling took a bit too long. And so I wonder if you have measured that, if you found biomarkers or behavioral markers to identify that, basically that moment that ideally we should stop and go outside and meet our friends or so.
Yeah. So we only looked at people's behavior as it was happening. So we didn't ask people about their regret. But I will say it's, there's a lot of hype about social media and negative affect, and the evidence doesn't support that necessarily. There's a lot of mixed results. There's no definitive results that being on social media leads to unhappiness or regret or et cetera. So, but our data didn't capture people's experiences after they left social media.
Hi, thank you so much for like this really amazing talk. It actually reminded me, I think, yeah, this year, sociologist Jonathan Haidt published the book about, like cell phones and the children. And it made me actually more curious about the topic, so I kind of started doing my own research about this. So one thing I would just like your perspective on is kind of given the digital age and how it's affecting the youth and maybe tech addiction and the idea that oftentimes we see like this terminology iPad kids, where it's almost like their iPad is like their actual parent compared to their human parents. So I was wondering, like from your perspective, understanding attention span and relationship with technology, do you see like any, in the meantime, like therapies or ability to actually see reversal in tech addiction, especially in like youth when it's like a very addictive, like actual like addictive behavior?
Yeah, that's a great question. So first of all, in my view, there's an opportunity cost. So when a child is on a device, they're not being outside. They're not moving around. They're not practicing, large-scale motor coordination. They're not having social interaction. So it's depriving them of the opportunity to practice and learn and experience other kinds of behaviors. So it may not be the social media itself, but it's the fact that it's depriving them of having other kinds of real-life experiences that can help their development. And yes, there is a way to help kids. You limit the amount of time that they're on their devices. And if a child is using technology, it's really important to do it in a public area so the parents can see what the child is doing. Educational programs seem to be fine, right? But there's a caveat because a lot of programs claim to be educational and they're really not. But it's really important to teach kids habits early.
Mm-hmm. Yeah, because a little bit of a follow-up, but I know like kind of seeing more in the news, a lot more public schools and stuff are kind of doing like tech bans in the sense of like no phones allowed even in the school and stuff like that. And I kind of see that as a pro and a con because it's like, I understand phones can maybe establish more of a rote, comfort in students, but also phones have actually like really helped progress the idea of like a computer in your pocket and you don't have to memorize a lot of information, but you have it on hand. So I was thinking like, what's your idea on like that type of balance of like technology for the good, but also kind of avoiding this behavior we seem to.
Yeah, technology and moderation.
Mm-hmm.
So I love technology. I'm excited about technology. I'm not a Luddite. I don't think we should get rid of technology, but we have to learn how to be smart using it. And it does start with kids. We have to teach our children how to be smart using it. And banning phones in schools is, in my view, a good idea. In fact, I did a study with colleagues in South Korea where we logged smartphone use in college classrooms. We find that young people in college spend about 28% of their time in lectures on their smartphones. Are they using it to look up lecture material and get further information? No. They're using it to go on social media or to text. So they're not using it in educational related ways. So I think there should be limits on smartphone use in schools.
Cool, thank you.
Okay, we have another question from online. First, thanks so much for your great talk. Do you have any ideas as to how your findings with attention span and engagement affect data we collect in many neuroimaging studies? So for example, even in real life, everyday settings, it seems that attention span is very brief. So I imagine this being a problem beyond task-based fMRI and including more naturalistic paradigms. Do you have any ideas as to how we might account for this in experiments going forward?
Very interesting. So again, not being a neuroscientist, it's a little bit difficult for me to answer, but there was a very good study that was done on mind wandering, and it was using EMAs where people were probed, at random points over the day, and to report what they were thinking. And then you could determine were they externally focused or internally focused. And it turns out they were mind wandering about 45% of the time, which is a lot, right? But it's natural. And we should consider that it's natural to mind wander. We tend to think that it's a terrible thing to be distracted when we're using our devices. It's human to be distracted. The problem is that when we don't have the agency to pull out of that distraction and get back to doing the things we ought to be doing, that's when it becomes problematic. So, we should give ourselves the ability to mind wander because it's natural, but at the same time, we also need to develop agency to have better control over when to pull out when this kind of behavior starts to become excessive.
Yeah, thank you.
Hi. So you were talking about switching screens. The duration is getting shorter and shorter over the years. I was wondering, I switch screens all the time, but I'm on the same task.
Yeah.
So it doesn't control for that, I guess, or.
Well, you're right. We're being agnostic as to what the larger project is. The idea behind it is that people's cognition is switching.
Yeah.
So we're switching so if I'm writing a paper, I might be reading an article, and then I go to email, and then I read something on the web. But it's all the same task. It's all the same project, writing an article. But my attention is shifting to different things.
Okay, got that. That makes sense. Okay, great. The other thing, you were describing experiments where you said the self-interruption is 50% of the interruptions, right? So you haven't been doing neurosensing, but there must be studies where people are doing neurosensing and observing the self-interruption. What is the state of the brain just before a self-interruption? Have you seen anything about that, or
I need to direct the question to this audience. I've not seen that in the literature in human-computer interaction or psychology, but perhaps the audience here can help out with that. Anyone seen any? Well, there you go. It's an opportunity for research, and it would be great. Yeah.
Okay, thanks, Gloria, again.
Okay.
Now we have a general discussion session. We don't have too much time left, but I guess we still can do it. So if Joe and Guillaume, can you also? Yeah, Gloria. I can start with a question to Gloria. You didn't mention that in your talk, which was super interesting, but I saw when I was doing a research on you. You also did research on, for instance, watching videos on high speed or podcast high speed, the effect of faster.
Yeah, that was in my Substack that I wrote.
Okay.
Yeah, people. Most people tend to speed up podcasts, and they do it at 1.5 times speed, even 2 times speed. And my commentary is that this isn't good for us, because yes, you can get the gist of the content, but it doesn't allow us time to contemplate or process the material in any kind of deep sense. And so the larger picture is that we're in this world where we're inundated with information, we're overwhelmed with information, and there's this urge to consume as much content as possible, and because we speed up audiobooks, podcasts, videos, because we speed that up, we crave even more content. And so it's this idea, it's the culture we're in, to cram as much possible into our day. And we're not processing that material in any kind of deep sense.
Thank you.
Yeah, thank you so much for the thought-provoking talks. This is kind of like a general question because it seems like there's a common trend in all three of the talks about kind of attention and engagement in, say, interpersonal psychiatry therapy and even watching movies. I was just wondering, when we are designing certain cognitive tasks and experiments, there's a lot of repetition that kind of goes into these experiments. Did you notice a certain pattern where a certain experimental design or a certain behavior or environment allowed for higher engagement during these tasks? Or just in general, is there anything that helps someone along in being engaged for a longer period of time than they usually do?
I know the opposite. So, basically moving to the podcasts has been hard. If we give visual stimulation, that seems to be, you can do that like 10 times, and the signal level doesn't drop off that much. But if you move to anything that's like a podcast or fables, we had a thing with fables, like the second time through, the stimulation is dropping away. And it seems like auditory content is easier to block out maybe than visual content. So we're constantly aware of it, more just because we need to avoid it.
Yeah.
But I think that's also part of the, our bias was towards really conservative kind of block design type of thinking. And the new semantic things that we're working with, like just bail on all of that. And it's just like really diverse semantic stories. The ones that we're using at the moment are Moth Radio Hour stories. So those are fairly, some of them are pretty distraught, emotional stories. And I think that, we're sort of picked because of that.
Yeah, on that, I would say, the kids are a very good population to understand what could answer your question. I briefly present this virtual avatar. When I deploy that in the child hospital to do a autistic screening, immediately the kids say your video game sucks. And so I had to collaborate with game designers and so on to make the thing gamified in a sense. And clearly it has a big deal for kids to be engaged and fun. And the second thing would be to have more continuous design rather than psychophysics type trial repeated thing. And in that sense, natural interaction and social interaction are really rewarding, and for the engagement it's very good.
Mm-hmm. So the best way to be engaged is after a break. And we don't tend to realize the importance of breaks, right? And if you're someone has very good self-regulation, you're going to be working straight through without a break. Mm-hmm. But and if you Google how to focus nonstop, you're going to see all kinds of consultants and courses that are urging you to focus 10 hours straight. I'm not kidding you. There is such a thing. But when we focus, and what we have seen is that a state of focus is correlated with stress. And people can't focus nonstop for extended periods. You need a break. In fact, the best break is to go outside. And a 20-minute being outside can help replenish the spent cognitive resources. And we've shown, we did a study where a mere 20 minutes walking outside in nature helped people have better divergent thinking, which is creativity. So yes, taking a break will help people be more engaged.
I see. Thank you very much.
All right, thank you so much for this fascinating session. I had planned to ask my question to Gloria, but now I'm realizing we have actually a really amazing opportunity because you're focusing, I hope I'm not oversimplifying this, but like focusing mainly on behavior, whereas Joe focuses probably mostly on neural measures, and Guillaume's sitting kind of in between physically and conceptually, I guess. So I would love to hear like all your opinions if you want to share. How much do you think we can learn from behavior, focusing on behavior? How much can we learn about the brain and behavior by focusing on behavior alone versus how much value do we add through neural recordings in the real world?
I think both are complementary, both are really important. So, you know, if you look at some data, we've looked at some data without understanding other aspects, understanding the context, without understanding people's own subjective interpretations. And you may not have an accurate interpretation of what's going on. So if you're just looking at signals, or you're just looking at, you know, quantitative behavior, it's not going to give you the full picture. So I think both neural signals and behavior and people's subjective interpretation of what's going on, these all make a more of a complete picture.
I mean, I guess, so moving into the semantic stuff, it's all kind of looking at there's kind of like some kind of matrix, I guess, which is behavior on one axis and the neuroimaging on the other one, right? And so that we're trying to integrate the two of them. There is a question, does the neuroimaging actually add anything? You know, that's also a philosophical question, I suppose. I think, you know, this is the type of question, like, does brain imaging help anything, that often gets asked at the Organization for Human Brain Mapping. And, you know, then it's like a pro-con thing, and like nobody can agree on anything. So, I don't know. I suppose where it really matters is if you can make a difference clinically. That's probably the usefulness of the clinically focused studies.
Yeah, I totally agree. I would paraphrase Thomas Insel, say like the brain comes first in some disorder like schizophrenia. And for some case where you can have early signs at the brain level, for instance, that cannot be yet detected at the behavioral level, then the brain definitely add. And after that, of course, there is like this mutual nourishing circulation of knowledge where like, and I would even not stop at brain and behavior. I would add genetics, subjective experience and phenomenology, GIS and geographic and social economic status and so on. Ultimately, I don't think we should be put those data in silo, but we should integrate them all together. So,
thank you.